Okay, so this is a PowerPoint review that we did in class on Monday. That's finding the five number summary. So this is our PowerPoint review, just the first few slides here. So in order to work with a 5-number summary, what I always want to try to do is list out the numbers. So this is giving us in a stem and leaf plot. So I'm going to go ahead and just list the numbers up here in order. So I would have 10, 13, and then I have two 21s, and then a 23, 30, 31, and 43. Okay. So again, all I did was take my numbers here. So I have a 10, a 1, 3, so 13, 21 twice, and a 23. And then I have 30 and 31 and 43. And then once I do that, I always want to count to figure out how many values are in my data set. So I can count my list here. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. And then I can count over here just to double check and make sure I didn't lose a number. So I have 2, 3, 4, 5, 6, 7, and 8. So for my 5-number summary, I want to know what is my lowest value here, or my minimum. And that's just the smallest number actually on the list, right? So these are in order, so my smallest number is 10. I also want to know what's my Q1, my Q2, or my median, right? It means the same thing. My Q3, and my highest. And so my highest value, also easy, so my largest value is 43. And so now if I want to find my median, I know there's 8 values altogether, so that means there's going to be the first 4 and the last 4 split up my data set. So my first half contains 4 values, my second half also contains 4 values. So that means there's no number left for the median. So I'm going to average these two to find the median. I can also just look to see that 22 is in the middle. So I can either add up my two numbers and divide by 2 to find my average, or I can just look and see that the median is 22. So my low is 10, my median is 22, my high is 43. So now for quartile 1, I want to find the median of the first half. And again, there's an even number of values. So that means I want to average those two numbers together. So I would do 13 plus 21 divided by 2. And that would give me 17. So that means Q1 is 17. And for Q3, the same thing. I have 4 numbers, so it's an even distribution, or even set of values. And so I want to find the middle. So that means somewhere in between 30 and 31. Or 30.5. So my 5-number summary, my lowest value is 10. My first quartile is somewhere in here, so Q1. My median is somewhere in here, or Q2. And my third quartile is halfway in between the second half, so that would be right around here, is Q3. So to find the mean, that symbol was X bar. And we find the mean by adding up all of the numbers, so we want to add them all up. And that symbol, remember, is the sigma, so Greek letter sigma. We want to sum all of our values and divide by however many we have. And so in that case, that's the formula, right? So X bar, we need to know this notation, we want to add all of the values, so sum the X values and divide by however many I have. So I'm going to add up all of these numbers. I'm not going to, show you that, but you want to add up these numbers, and you would get 192, and then divide by however many values, which are 8. So the mean is 24. So now to find the standard deviation, we want to take our data values. So I'm going to do this on the side over here. So to find the standard deviation, I take the given numbers and I'm going to subtract the mean from each of those numbers. So I'm going to do the 10 minus 24. So I'm going to do 10 minus 24. And then I'm going to do 13 minus 24. 21 minus 24. 21 minus 24. 23 minus 24. 30 minus 24. 31 minus 24. And finally 43 minus 24. So I subtracted 24 from all of the values, and then I want to square them. So then when I do this, I'm going to do negative 14 times negative 14, 11 times 11, and so on down the line. So negative 3 times itself, negative 1 times itself, positive 6 times itself, 7 times 7, and 19 times 19. And then once I get here, I want to find the mean of these values. And that mean, remember, is equal to the variance. So I want to add up those values. So I want to find the sum of x minus x bar squared, which is 782. And then divide by the number of values I have, which is 8. So I have 8 numbers here. And then that gives me sigma, this is lowercase sigma squared, which is also called my variance, of 97.75. So remember, that's my variance. And then to find the standard deviation, I want to get just sigma. So standard deviation is going to be the square root of 97.75, or about 9.9. And so then that's standard deviation there. Okay, so there's for part B, the mean and the standard deviation. Okay, and then finally for my 30th percentile, I want to figure out how far to count in. Looks like one word. So it's the number of data values times my percentile. So I have 8 pieces of data, and I want to find my 30th percentile. So that means I'm going to multiply by 0.30. So then 8 times 0.3 is 2.4. And then the rules for percentile is if we have a whole number, we add 0.5. And then if we have a decimal, we always round up, even if it was, you know, little, right? So that's a rule. So I got a decimal, so I want to round it up. So 2.4 rounds up to 3. So even if this had been 2.1, it would still be 3. So that means I want to count in 3 numbers to find my 30th percentile. So I count in 3 numbers, so I'm going to go back up here. So 1, 2, 3, so 21 is my 30th percentile. Okay, so that was the first slide. Okay, so for this one here, it says for the following 5-number summary, let n equal 15 the number of data values. So I have an odd number of values. And so they're telling me my lowest number is 2, and my highest number is 16. And then I know altogether there are 15 values. So then the question, is there an element in the data that must have the value of 12, which is my median or quartile, and then why or why not? So because there's an odd number of values, when I split up the set, my first half is going to contain 7 values. My second half will also contain 7 data values. So that means my median will be 12, right? So because there's 15 altogether, so 7 in the first half, 7 in the second half, which is a total of 14, leaving the 15th to be my quartile 2 or my median. So yes, it does have to be an element, and that's because there are an odd number of data values. Okay. So then let's decide on quartile 1 and quartile 3. So we know for sure 2, 12, and 16 are pieces of the data set. Does 10 have to be? So in the first half, there's an odd number of data values. So that means quartile 1 also has to be part of my data set, where there will be 3 numbers here, whatever they happen to be, and 3 numbers over here, whatever they happen to be. So I have 2 and then 2 others, right? So I have 3 in the first half, 3 in the second half, and then that would be 6, and my 7th one is quartile 1. So that's the same for quartile 3, that I would have 14 in here for Q3, 3 numbers in front, 3 numbers behind. Okay. So how many elements are in the data have to be less than quartile 1? So how many elements are there less than quartile 1? Well, there has to be 3 elements, right? And there would have to be 3 elements above 14 for the same reason, right? Because if this is in the middle of 7 pieces of data, 3 here, 3 here. But now, is there value greater than 14? Well, for sure this one, right, is bigger than 14. But couldn't the next 2 numbers also be 14? So there's going to be at least one, right, that is bigger than 14, which would be your high, which is 16. But couldn't the other 2 numbers that are right in here be 14 as well? And so would that make them greater than 14? No, it would be equal. So at least 1. And at most 3. So somewhere between 1 and 3 pieces of information would have to be greater than 14. So 16 for sure, and then maybe the 2 here, because it could have been that these were both 14 as well, right? Because we can have a mode where 14 shows up 3 times. And that would be the same for this one as well. So below Q1, so 10. 2 is for sure below 10, but are we guaranteed that these are as well? And we're not, right? We don't know if these are 10 or are they 3 and 4. So we know somewhere between 1 and 3 pieces, right, are less than Q1. Okay. All right, so are there any outliers, and provide mathematical proof? This part right here is a part that sometimes gives us trouble, right? So we can look at this and we can see, all right, between 10 and 16, these are all bunched up, so 2 is probably an outlier. And so we're going to go ahead and actually show mathematically that it is. So the first thing we want to do is we want to find our inner quartile range, and that's when we take the value for Q3 and then we subtract Q1. So we want to see how spread out our box is, right? Because this is a box and whisker. So how spread out is our box? So we're going to do Q3 minus Q1. So my inner quartile range is 14 minus 10, which is 4. So that means my box is a distance of 4. And so how far out can our whisker go? And our whisker can go out 1.5 times more than our box. And then beyond that is called our outlier. So I always multiply 4, or my inner quartile range, by 1.5, right? That's the magic number. We always multiply by 1.5. And so then 4 times 1.5 is 6. So then this means I can go beyond my quartiles by 6 units, right? I can go beyond my quartiles by 6 units before I get to outliers. So if my quartile 3 is at 14, I can go 6 units beyond that, right? That's the magic number. So that means I can go anywhere up to 20, and anything beyond 20 is considered an outlier. So in this case, my highest value is 16, so this is not an outlier, right? So outliers would be my Q3 plus 6, which would be a total of 20, right? But I don't really care what that number is because I'm not going to graph it. I just need to make sure that this number doesn't go beyond 20. So we're good, right? No outliers on this side. So now let's check the other side. So this is at 10. I can go 6 below 10, right? So I can go this way, 6 units, so 10 minus 6. So then to find my outliers over here, I would say, okay, for my lower values, I would do 10, because that's Q1 minus 6, which is 4. So the farthest I can go on my whisker is to 4. Do I have any numbers below 4? And I do, so then 2 is an outlier. So it's still graphed, right? But it is now an outlier. My whisker can only go to at most 4, or at least 4. So I have an outlier. Oops, started to write Q1. So Q1 minus 6 is 4. So then, therefore, I have an outlier of 2. So 2 is considered an outlier because it is below 4. Okay, so for this one, we want to create a modified box and whisker plot. So we want to find our 5-number summary first. So our lowest or minimum value, so this is in order for us already, is 11. Our highest or maximum value is 40. And then we want to find our median, so we have 9 pieces of information. So there's the second half, there's the first half, and there's our median or Q2. So here is Q2, or our median. And so now I want to find Q1, which is the median of the first half of the data. So I'm going to look at my first half. So I have 4 values, so an even set. So that means it's going to be in between 15 and 18. So I want to add 15 and 18 and divide by 2. And that gives me 16.5. And then I want to find Q3. So same thing. So I want to find the... So let me write Q1 here, is somewhere in there, right? And then Q3 is somewhere here. So there's the second half, so I want to find the median of the second half. So somewhere between 22 and 24, which is, I can tell 23, but still we're just averaging, right? And dividing by 2. So now the modified piece is kind of a tip. So whenever they say modified, it means you probably should look for outliers. And then additionally, if you look, that 40 seems pretty high compared to all the rest of the numbers. So I'm guessing 40 is an outlier, but I can't guess. I need to verify it mathematically. So I'm going to find my interquartile range. So I'm going to do Q3 minus Q1. So I'm looking to see how wide my box is. So my box is 16.5. So then I want my whiskers to extend 1.5 times past the box's width. So I multiply always by 1.5. And so I'm going to multiply those two together. And so then that gives me a number of 9.75. So that means I can extend beyond my quartiles by 9.75. So if I'm at Q3, so Q3 is 23, the farthest I can go is 9.75 past that. So I can go 23 and then another 10, almost 10 away from that. So I know that my upper boundary is 23 plus 9.75. So then anything above 32.75 is considered an outlier. So then this is my outlier. Right? So we go up to Q3 and we go 9, almost 10 past it. So anything beyond that is an outlier. And now for my lower bound, so how far is that whisker going to go? Or at most, how far is that whisker can go? So I take Q1, which is 16.5, and I can go left 9.75, right? So my whisker can at most go 9.75. So I'm going to do 16.5 minus 9.75. Which is like 15 or something like that. And so it's definitely, I mean, what is that, around 6 or something? So 11 is well above that, right? I don't know exactly what that number is because I didn't work that out. But I do know that 11 is definitely bigger than this, right? So if I subtract those two values, I would get like 6, around 6. And then that is bigger than that. So there's no outliers on this side. Okay, so now let's go ahead and graph it. Okay, so I went ahead and counted by 5s here. So my lowest value is at 11, so I'm just going to dot there. And then my Q1 is at 16.5, so somewhere around here. Q2 is around 19. Q3 is at 23. And I have my highest at 40. But then this is an outlier, right? So this is my outlier. So then my whisker is going to go to the next highest value, which is 24. So this was at 23, so my whisker is going to be really small here. So these three numbers create my box, right? My inner quartile range and then the median. So from Q1 to Q2 to Q3. And then I have this itty bitty whisker here. And then my whisker to the left. So I have my whisker going to 11. And then my first quartile, my median, my third quartile. My whisker now goes to 24 because 40 turned into an outlier. Okay, so then let's take a look at the next one here. So which of the following has a larger standard deviation? So remember, the standard deviation helps us with the spread, right? So graphically, you know, what's our spread? And the smaller the standard deviation, the tighter grouped everything is, right? So if we have a small standard deviation, that means our entire class had about the same grade. If we have a large standard deviation, then everybody was all over the map with their grades. So I'm just looking to see which one has a tighter group this way, right? Which one has a tighter group this way for a small standard deviation, and which one is more spread out this way for a larger standard deviation. So the larger the standard deviation, the larger the spread. So this one has a larger spread, right? Because this group right here, this group of people, are all clustered together except for this one person here. But if I look here, you've got some way out here and way out here, so this will have a larger standard deviation. Okay, same with the box and whisker. So the longer the whiskers, right, the more spread out everybody is, so the larger the standard deviation. The shorter the whiskers, right, the smaller the box, assuming all the scales are the same, the smaller the standard deviation. So this would have a larger standard deviation. Okay. Right, and then one more slide. Okay, so describe the distribution. So we're talking about skewed left, skewed right, that sort of thing. So if I look at my box and whisker, this is my median. So do I have more or less data to the right or to the left? So I have more to the right, so this would be skewed right. Okay. So this is the same idea, just we put the information on the table. So I want to figure out what my data is here. So there's from 10 to 2, I'm 8 apart. From 14 to 16, I'm 2 apart. So I have more to the left, so I would be skewed left. Right, there's a longer spread here. Okay. So find my highest. Look to see what do I have more of. And I'm going this way more, right? So we look at the tail, so then this would be skewed right. For the stem and leaf, I'm going to turn it this way. Here's my highest value. So left and right, I have more this way, right? The bump is on the right, so it's going to be skewed left, right? So skewed left. If I look, there's more here. Okay, and that's it for this recording.